Can you hear me? Can you see the geometer sketchpad?
Yes, teacher.
Okay, both also can, right? Oh, this is your question number 5, and this is your question number 6. Question number 6. Okay, so this is your question number 6. I have prepared two more questions. The simpler one here, and this one, another simpler one here. So we have this one not so simple also, right? So I prepared one simple one difficult one. Then the one that you ask is this one. They are actually the same. You see the shape here? It's the same as this one here. So if you don't know how to find this, then surely this one you cannot, right? You don't know how to do. So we just wait another 2 minutes. Another 2 minutes. Ang Li Wen. Sorry, the other day no recording because I forget to put on the record button. Today I put on the record button already. The other day forgotten, but I print the screen and put it inside the Telegram group. Okay. Okay, right. So we start. Now, this question, right? Now, if you, I read the question first. In the diagram on the right, O is the center of the circle with radius 9. So in this question, you have a circle, radius 9. Okay. The minor arc AB subtends an angle of 140 degrees at the center. 140 degrees at the center here. And tangents at A and B meet at C. Calculate AC in cm. Calculate the area of the kite shape OACB in centimeter square. Now, first of all, if you you are given a circle and also two tangents, one tangent AC and another tangent BC. Now I don't know whether you have learned this in your Form 4 mathematics or not. Tangent means what? Here 90 degrees. Okay. Tangent means what? Here 90 degrees, right? 90 degrees. So tangent means 90 degrees. Okay. Now, if this is 90 degrees and this is also 90 degrees, they are all tangent to the circle. They are called tangent to the circle. This line is tangent to the circle at A. This line is called tangent to the circle at B. And when these two tangents, they meet each other at the point C, they will produce two identical right angle triangle. So these two right angle triangle, ACO and BCO, they are identical. Why they are identical? Because this is 9 cm, right? Because this is 9 cm, then the other one is also 9 cm. The other one here is also 9 cm because both of them, they are the radius of the circle, right? But when we solve the problem, we are not going to look at both the right angle triangle at the same time. We are going to look at one right angle triangle a time. Okay, so before we look at uh, the question how to answer, you draw one line here, OC. In your original diagram, there's no OC. Now once you drawn the line OC, you realize that there are two identical triangles there, right? This one and this one, the two identical right angle triangles. So we have AOC and BOC. They are two right angle triangles. Now right angle triangle is because this is the tangent. Now they are also identical. Why are they identical? Because the two radius, this is the radius, this is the radius. So both of them, these two right angle triangles, they are identical. Right. So now we look at one side. Okay, one side. Let's say we look at triangle OAOC. So this side, this triangle AOC. So like this, or this one and this one. This one is we want to look at this side. Okay, so what can we see? Now, because it's a right angle triangle, then AC divided by OA. Where's AC? AC is this line. OA is the radius. So AC divided by OA is tangent of this angle here. Now this angle here is 70 degrees because the whole thing is 140 and you cut it into two. Not cut into two lah. The actual one is called bisect. Okay, you bisect this angle into two using the line OC, and one part is 70, the other part is 70. So this is 70. So using trigonometric ratio, AC divided by 9. This is AC divided by 9. Okay, so these two sides, the ratio is tangent. So it is tangent 70. So AC is equals to 9 times tangent 70. That is 24.73. Okay, right. Okay, next part, we want to find the area of the kite. Okay, now area of the kite is area of this whole thing, OACB. But we don't find the area of the kite yet. We try to find this yellow area first. So this yellow area, because it comes from a right angle triangle, I can use half base times height. So the base is 9, the height is this one, AC. AC is 24.73. So half base times height is half 9 times 24.73. So it is 111.27. But this is not This is not the area of the kite. It is only half the kite. So you want to find the whole area of the kite, you have to multiply this by 2. You multiply the area of the right angle triangle by 2. Okay, so you multiply by 2 and you get 222.55 centimeters square. The answer is 222.57 given in the textbook, 222.57, right? Now they get this answer probably because they round off a lot of numbers. Those days they don't have calculator, so they use back the trigonometric function from the four-figure table. Probably you will have a slightly different answer. But four significant figure. So this four significant figure you round off to 222.6. Here also will be 222.6. So it's okay, right? So far can follow or not? When you draw the tangent, it is a right angle triangle. When you draw the right angle triangle, you use trigonometric function. So far, okay or not?
Can, teacher.
Can. Other girls? Other girls? Okay or not? Okay, Sherwin said okay. Okay, so now the second part is over. We find the area of the kite, which is the sum of the two right angle triangle. Next one, we want to find the area of the minor sector OAB. Where's OAB? OAB, oh, this part. Very easy, direct. It's just a direct only, right? Direct. So direct one will be here, right? So area of the right angle triangle, area of the sector, sorry. Area of the sector is half r square theta. This sector here, this sector, half r square theta. So half r is 9, 9. So 9 square. Theta for this sector is 140. But 140 you have to convert to radian. Multiply by pi divided by 180. So use your calculator, do this in one step, you get 98.96. The answer given is 98.98. Difference, a little bit difference. Okay, a little bit. Okay, so this is the area of the sector. Area of the shaded region. Shaded region is this part, the purple part here. The purple part is outside the circle. Outside the circle, right? This part. This part. Okay, how to find? So the area of the shaded part is the area of the kite. That means the area of this whole quadrilateral minus the area of the sector, minus the area of this sector here. Then you will get outside the shaded part. So area of kite you have found earlier to be 222.55. Then area of the sector 98.96. So when you subtract the two, you will get 125.59. This time, 125 or 123. Somebody please check my subtraction correct or not. Sometimes I also read wrongly the calculator. Anyone? 222.5.
123.
123, yeah.
123.
Minus 98.96.
Yeah.
123. So I change to 123. Okay, 123. So save. Okay, so far any question or not? Can understand or not how to find the shaded area? Use the area of the kite minus the area of the sector, then you get the outside part.
Can, teacher.
Can. Okay. Can, so okay. Okay. Right. So next one. We look at the next question. This one, Now this one, I read the question again, right? So we concentrate on the first panel first. This one. Now the diagram on the right shows a circular ventilation window in a hall. PQR. PQR is this part. PQR is a major arc of a circle with center S. So there's a circle here, center S, and this part is a arc. Okay. The line OP and OR are tangent. Okay. So here is OP and here is OR. They are tangent to the circle. Okay. OP and OR are tangent to that circle. Four other panels are identical in size to OPQR. O is the center of the ventilation window that touches the arc PQR at Q. PQR touches the circle at Q. Okay, so again they say OPOR are tangent to the circle. Now, if you look at this, this is a circle. This circle is actually something like a window. Window, then this have the fan. These are the fan. These five pink color panels, they are the fan. And the blade of the fan. The blade of the fan, it will be rotating all the time, right? This is like blade of the fan. Now, the blade consists of a sector and also something like a triangle here. A sector and a triangle here, right? And this sector and this triangle is formed by the tangent at P and the tangent at R. Then when we talk about tangent, it means that the angle is 90 degrees. Here 90 degrees, on the other side also 90 degrees. Okay. Now it is given that this angle here is 60. So it means that this angle here is 60. This angle here is 60. Half of it, right? Not the whole thing. So this angle is 60. And you are also given OS is 6 cm. OS is from the center of the big circle, right? Center of the big circle until the center of this small circle here. So the distance between the two center, they are 6 centimeter. So far, understand the question or not? So altogether, there are 5 blades of this ventilation fan, and they are arranged in this manner. They are spaced equally apart. So they are spaced equally apart. Okay, so shall we start? Okay, right. So consider the right angle triangle OSR. OSR. So this is half of the kite, half of the kite. Then RS, okay, so we consider this right angle triangle blue in color, and if you use the SR, which is the radius of the circle, divided by this length here, OS, which is the hypotenuse of this blue color right angle triangle. So RS over OS is the cos of this angle, adjacent over hypotenuse. So when you bring the OS over, OS cos 60, OS is how much? 6 centimeter. Cos 60 is 0.5. So therefore, RS is 3 centimeter. That means the radius here is 3 centimeter. SR. Proved. Okay. Next one. Next one, okay. Next one, calculate the area of the panel OPQR. OPQ is here, R. So it's actually this sector plus the two right angle triangle, right? Okay. Now area of the kite. This is the kite, OPSR. OPSR. Area of this kite is twice the area of this right angle triangle. Okay, it's the twice the area of this blue color right angle triangle. So this blue color right angle triangle you can find in many ways. Now one way is to use what you have learned last year, that is the solution of triangles. Solution of triangles is the area is half BC, then sine of the angle at the center. So here we have so here we have 3 centimeter, and here we have 6 centimeter. So 3, 6, and the angle at the center is 60. So I say the area of this blue triangle, right angle triangle, half BC sine A, which is half, the length here is 6, the length of the other side is 3, then sine of the angle at the center, sine of this angle, right, 60 degrees at the center. But this half BC sine A is only this side, only this part of the right angle triangle. There is another right angle triangle on the other side, so I have to multiply by 2. When I multiply by 2, I will be able to find out the whole kite. This whole kite here, what is the area? So after multiplying by 2, I found out is 15.59. 15.59, right? So this is the area of the kite. What is the area of the sector? Half r square theta. Half r square is 3 square. 3 square. Then the theta here is not the theta on this side, the minor arc, but the theta is the angle for the major arc on the other side, because we want to find the area of the sector, the major sector on this side. So we have to use the angle, the bigger angle. So the bigger angle here is 360. It's actually 360 minus 120. This is equals to 240 degrees. 240 degrees. That's how we get the answer. That's how we get the 240 here. Right? That's how we get the 240 here. 240 is 360 minus 120. 360 is the angle of the circle. 120 is the angle on this side. 240 is the angle on the other side. So that's how we get this. So simplifying, we have cancel, we get the answer is 6 pi. 6 pi is 18.85 centimeter. Okay, so this value here, 18.85, is the area of the sector here, area of sector. Then this part, 15.59, is the area of the kite here. So if you want to find the area of the whole panel, whole panel is what? The area of the whole panel is area of kite plus area of major sector. Okay, so area of major sector plus area of kite, when you add these two numbers together, 34.44. So the answer is here, 34.44, correct. Okay, so far can follow or not? So far can follow?
Teacher,
Yes.
for the area of kite,
Ah,
why half BC sine A?
oh, okay. Y half BC sine A. Now, let's see. Okay, we copy out this one. We copy this. Okay, so okay, so now this is 6 centimeter here. You remember the formula for area of a triangle? Okay, so let's say this is A. Okay, so this one is, let's say, B. This is, let's say, C. Let's say this one is B. Okay, let's say this one is, this is B. Okay, ABC. Then this one is small a. This one is small a. This one is small b. This one is small b. Okay, this is small b. Small b. Then this one is small c. This one is small c. Okay. Okay. Right. So we have something like that. So this angle is A lah. This angle here is A. Okay. This angle here is A. So we want to find the area of this triangle. Okay, if I want to find the area of this triangle here, okay, if I want to find the area of this triangle, what is the area equal to? The area is equals to half BC sine A. Okay, you remember this formula when you learn this in form 3, form 4, sorry. Can remember this formula or not? This one. So it means that you take the B and C. Can you see that this is B, this is C? Then sine of the angle at the center. Angle at the center. Okay. Now, this angle at the center here is 60. Angle at the center is 60. So I replace it with this one. Right? I replace it with area equals to, okay, what is the B here? What is the B? B is 3. So it's 3. Then what is the C here? C here? Or the C here is 6. So times 6. Okay. What is the angle at the center then? Angle at the center here? Oh, angle at the center here is 60. So sine 60. So can you see that the area of this is half BC sine A is half these two angle, these two side multiply with the sine of this angle. So over here we have this triangle. So the area of this triangle is half BC sine A. Now, is there any other way to find out the area of this triangle? Yes, there's other way. Because this is right angle triangle, so you can always use this OR times by 3. You can always use half base times by the height of the triangle. Or if I want to use that way, I have to use Pythagoras theorem, find out what is this OR here. After finding out OR, then I have to use half BC, half base times the OR again. That is another way of finding the area of this right angle triangle. Is that okay?
Okay, teacher.
Okay, can,
Mm.
right. So now we go back to this one. Okay, we go back to this. Okay, so that's why I don't want to find the OR first. I just straight away use whatever I know, 3 and 6. Right. So now this piece, this piece here, it will rotate like that lah. The whole thing altogether, there are 5 pieces. So these 5 pieces, these 5 panels here, they will rotate. The 5 panel like that, they will rotate. Okay. So when this 5 panel rotates, the window has a rotational symmetry at O to be the nth order. Find the value of n and label and the area label T between two panels. Okay, right. Now for this flower pattern like that, then they have to rotate one time, rotate. So when this thing rotate, the Q will overlap on top of this one. Then this one will overlap here. This one will overlap here. So how many times they rotate, how many axis of symmetry before you go back to the same position here. Now, if you look at the flower here at the center, the pink color flower, when you rotate one time, the center line here, this center line here, right, will move over to this line here. Okay, will move over to this line here. So they will rotate, move, rotate. So how many panels they have? Then what is the angle in between each panel? Right? So the angle between each panel, how many panels are there? 5. Okay. So if they are altogether 5 panels, that means they can rotate and overlap on top of each other 5 times before they make one complete round. Oh, it means how to say? When they rotate, the panel can match exactly on the same image there. The object they rotate, they can match exactly the same on the object. The image can map exactly onto the object, or the object is the same as the image like that. So they rotate. So how many times they can rotate? They ask you 5 times lah, because there are 5 panels. After moving from one to another, and then finally you come back to here. So they're all together 5, because there are 5 panels here. So 5 panels, what is the angle of rotation from one panel to another? 360 divided by 5 is 72. So this angle here is 72 degrees. This angle here, 72 degrees. Okay, so it will be one rotation like that. Okay, one time you rotate 72 degrees. You will move from one panel to another panel. Okay or not? So far can understand?
Can.
Okay, so this angle is 72. You bear in mind, this angle is 72. Then I want to know what is the what is that what is this area here, this yellow color area here, that when they move, what is the area of this yellow color thing, the locus of the movement. So because I know this is 72, so this yellow color sector, the angle subtended at the center must be 72, but the radius is different. Here they tell you 6 cm is from here to here, and here is 3 cm. They tell you the radius here is 3 cm at the side here, SR. But then the radius on the other side here is also 3 cm. Okay, it's also 3 cm. So when I use this 3 cm here, plus with the 6 cm, so what is the radius of the yellow sector? What is the radius of the yellow sector? 3 plus 6. So it will be 9 cm. Now, if I want to find the area of the yellow sector, it will be half r squared theta. Half is half. R is 9 because of this length plus this length. Then the angle of this sector is 72. And I have to change it to radian, right? So okay, so I've changed, then you multiply, you can find the area of the yellow sector. Now I want to find the area of this part. Now can you see that this part falls within the yellow sector, and the area of this blue part here also falls within the yellow sector just now. Okay or not okay? Okay and not okay? The sector, the big sector, the angle of rotation, and inside this sector there are two parts. Half from this panel, another half from the other panel. But these two parts that is now is look like green color, these two green color, you add them together, then they become one whole panel. So if I want to find this yellow color that is at the center between the two panels, I use the area of the yellow sector minus these two green color, I will get the area at the center. Okay or not okay? Not okay, then I repeat. Huh?
Uh, okay.
Okay, so I have to
Mm.
use the area of the yellow sector minus the area of the two green panels. But which the two green panels, half of it combined together become one again. So now, if I want to find the area between the two panels, that is this one, the yellow color, there's the yellow color, I use the rotational sector, the yellow color sector here. This yellow color sector here minus the area of the panel. Yellow sector minus the area of panel, then I should get the area between the two panels. So what is the rotational this sector here? 50.89. 50.89. What is the area of the panel? Oh, awal sudah cari here. 34.44. But this is the area of one panel. Then you tell me, oh, this one got two, but this is half. This is half. You add together, it become one. So it's still minus one panel. So answer will be 16.45. 16.46 here is given. The last decimal place a bit of different, never mind. So far, okay or not? If not, then I will explain one more time.
Okay.
Okay, okay, now is time already. So thank you very much, and we stop here, right? We stop here. Time. I will share the thing.